My name is Jonathan McGon, and this is going to be the bonus assignment or the solo assignment for the design of aerospace experiments class, EAS3810C. The first part of my assignment is going to be for the Xfoil portion. So first and foremost, we're going to open up our Xfoil. Just like this. We have this kind of code-looking type page. We're just going to load in, I'll just show you how to do the NACA airfoil just for simplicity reasons. If you wanted to load up the Eppler airfoil, all you have to do is do load, and then basically you just, my Eppler airfoil is right here, E385, so you just do E385.dat, and you click enter and it loads up your airfoil. But in regards to converging and things like that, that was a little bit more difficult to do. So for demonstrative purposes, I'm just going to load up a NACA airfoil. So I'm going to do the symmetric airfoil, NACA 0010. Here it gives you the number of panel nodes, it gives you thickness and all that. So there's a technique that I use. You type in pane, it just smooths things out a little bit. You can then click PPAR. It gives you a kind of a brief demonstrative overview of what your airfoil looks like. Let's get this out of the way for now. We can make our trailing edge and leading edge panel density to 1 by doing T space 1. And then that's all we really need to change. So as you can see, this is now changed. We can click enter to get out of this screen. We then need to do we need to type in opper, which will give us to the operation screen. The opper with a little I after it means it's in viscid flow. To change it to viscous, you just type V. For this specific project, we need to use 2 different types of Reynolds numbers, 375,000 and 1,250,000. So for this demonstrative purpose, I'm going to do 375,000. Just like that. Beautiful. And then once you're done this, we then have to sequence the angle of attack between -5 and 20 degrees with increments of 1. However, if there's an issue with convergence, it is best to do smaller increments. So for example, rather than going -5 to 20, you go from -5 to 0 and maybe do 0.1 degree increment. And that just allows a better convergence to occur. So really quickly, in order to download this file and the data that you can collect, you just have to type in PACC. Then you can just type in a file name, whatever you want it to be. I have all my data saved in, this is project 3, part 1. All my data that is written from Xfoil comes out here. But just again, for demonstrative purposes, I'm just going to type in, I don't know, just call it airfoil. Click enter again. So now you see this A here, polar accumulation is enabled. That means all the data being collected is going to put into that airfoil file. So I guess let's do a sequence. So in order to do a sequence, you go ASEQ. We're going to go from -5 to 20 with a 1 degree increment and click enter. And as you can see, there's a couple points that did not converge. Specifically, alpha is at 9 degrees. In order to fix this, I found that you can actually do an alpha sequence of a sequence from, you basically want to do it around the area that didn't converge. So we'll do since alpha at 9 degrees didn't converge typically, we're just going to go from 8 degrees to let's go 12 degrees with 0.5 increments. And as you can see, we did converge, and that's just a method in order to get the proper results. So you're going to get different files. Your files are going to be located in your XLR, or not XLR5, my apologies. I believe this, oh yes, wait, did it save to desktop? Maybe it's saved to desktop. But if you search for that file, it will come up and you'll have all the data that is necessary for that specific airfoil. And I'm pretty sure that's going to conclude this portion of the assignment. In order to get the specific factors that are asked for this assignment. I'm just going to show you really quickly how I did things. Let Excel load up for a second. So here I've separated kind of each category a little bit. So here we have the NACA 0010 airfoils at Reynolds number of 375,000. And this kind of goes all the way across for all the different airfoils. In order to plot your lift coefficient versus angle of attack, you can get your lift slope curve just by probably taking the trend line from -5 to approximately 7 degrees and just getting the equation for that. The rest of these can just be simply plotted along or just based on the data collected. This is where the trend lines come in, and then these are for the Reynolds number of 1,250,000. So yes, that will conclude this portion of the project for Xfoil. The next video will be regarding the XFLR5 portion of this project. Thank you for watching.